Hello, hello, everyone. GM, good morning, good afternoon, good evening.
Good afternoon.
I'm good.
Good evening.
Good
Hello,
morning.
hello. People are still joining. So welcome everyone for the lesson 4, where we finish the content for this week, and I should get you all prepared for a weekend project. A project that you are all going to do in a group. You have your groups already in Discord, and you're going to deploy one smart contract and interact within each other using Remix, using a testnet, a public testnet within this weekend. I'm going to ask but the delivery in a very simple form, just a small report, open-ended report, a Google Docs or a spreadsheet or whatever you prefer, with the transaction hashes of these interactions. Okay, I'm going to explain about that. And in today's lesson, we are going to just finish understanding the function calling flow, and we are going to use that to create a sample smart contract like this, with some sort of access control. We're going to understand this idea for you to use within this weekend. Okay, so this lesson should take about 100 minutes or so, and I'm going to give you some extra reference material, the homework for you to complete before next week, okay, to get you ready for the weekend project. Sounds good. How did the week go for you so far? Getting started with smart code development, things are falling in place, getting to know the EVM. The answer is yes, we are in a good track. So let's get started with the smart contract that we had yesterday at the end of the lesson, where we could call all of these functions here, and we can use this smart contract as a sandbox, as a lab for us to explore all the things that we saw in the last 3 days. We can explore with this variable, we can explore with the visibility and mutability of the functions to see what happens, what works, what doesn't work. For example, if this function restore here is internal, if I change that for external, what stops works, this stop working because this cannot call it anymore, you see? So this is now a sandbox that you can try a lot of different things that we saw in the last weeks. Okay, so if you are still confused with some options or some parts of the syntax, of course you can ask me too, and we can try it out different things here. This smart code is not doing anything useful in specific, but it's very useful for educational purpose. Okay, so you can tweak around, you can change things. It's a great demonstration of the capabilities of Solidity for targeting the EVM. There is one more part of the EVM that we did not cover yet in fully detail, but I didn't mention in the past. That is the function calling, the calling signatures for these functions in a smart contract. And we're going to see what is a method ID, how it makes the function callable from outside or not, what is the signature of this function, and we're going to see these two kind of functions, testing them with external call using interfaces. So it's going to combine the interface stuff that we did in the last lessons with this new content here, okay? The idea is that whenever we are calling a function for the EVM, why should we put so many words at the front of a function? Why should we put visibility, mutability, what expect to return, and all inside a function? Because we are building the function selector. Okay, this is something that happens in the EVM level. Whenever we are calling a function in a smart contract, we are not going to pass the whole string of a function name. We're going to pass 4 bytes only. Let me show that for you. I can pick my MetaMask here. I can show the past transactions that we did. And you're going to see that whenever we are calling a function, we are only passing 4 little bytes, 8 hexadecimal characters that would compose 4 bytes. Let me show that for you. Here, we called set text in that function call, but let me view the input as raw, original. But there is no parameter with the string set text here. The EVM doesn't even know that the name of the string is set text. For the EVM, the name of the function is 5D, 3A, 1F, 9D, 4 bytes, each 2 hexadecimal characters. They would compose 1 byte, see? So if I decode this input, I know that I am calling the function set text with the new text of type string. Matheus was here. But how? I know that I'm calling the function set text because this method ID is mapped here at Etherscan, not in the blockchain level, with the function called set text. Someone has validated this smart contract in the past now and did this function. If I put another function named potato, maybe I'm not going to have that stored in Etherscan, I don't know. But what I'm trying to say is that all function calls should start with those 4 bytes. This is the function selector that is calculating by picking the hash of the name of the function and the type of the parameters, pick the hash of that, and then pick the first 4 bytes of this. So if you change the name of the function or the type of the parameters, the signature would change. And this is all that the EVM knows. The EVM doesn't know that the name of the function is transfer or transfer from. They just know that this is the signature and this is the signature that we have. Let me show you that with interface. Even before we speak about the receive and fallback functions, let me show you that with an interface. Let me clear this smart contract a bit. I'm going to take some functions away. They won't do no harm, but just for the sake of simplicity, okay, I'm returning this contract to this state. So I have initial text, I have hello world, I have set text, I have the construction there with initial text, okay? And I'm going to create one interface. Interface. I'm going to create it from scratch. I'm not going to copy from the lesson 2, okay, from the previous lesson, because I want to do some things correct and some things incorrectly. So I'm going to call this interface hello world. Okay, or hello world interface, whatever that you would like to call it. And I'm going to put some signatures correct. For example, the function hello world here, I'm going to put there correctly. A trick to create interfaces, you can just copy the function definition and then change the visibility to external. Okay, that would work. Oops. I'm going to copy the set text correctly too. And I'm going to put the visibility as external. And I'm going to create a new function. A function that doesn't exist in that contract hello world. A function, let's put a function get inverted text or get random text. I don't have this function in my smart contract, people. But I'm creating here in the interface. I'm going to put exactly as hello world here, get random text. Okay, would be a function that would return a random text for me when call it. Okay, but I don't have this function implemented in my smart contract. Okay, so I created an interface with those three things. Let me copy there for you. If I try to attach this interface to hello world, I'm going to have a problem. Is I hello world, capital words, right? If I try to attach this interface to my smart contract, I'm going to have a problem because I don't have the implementation for get random text. So for this interface would be very helpful, but I'm going to remove that. I don't need this today. So I have an interface I hello world that when attached to a hello world smart contract, I would have two functions correct and one function incorrect. Now I'm going to ask you, what do you expect to happen when I try to attach this interface? Maybe you'll raise your hand and chat to me, or maybe you'll want to answer that in the chat. What would you expect to happen? No expectations? Nothing? Vladimir is saying that we expect to get an error. I would expect you. Everyone agrees on that? It would be nice if we got an error. Okay, I'm going to deploy. I'm going to deploy that hello world to my virtual machine blockchain. Okay, I'm going to pick the address of this deployment, and then I'm going to try and attach hello world to it. Ideally, we would have an error here when I try to attach. This interface is not compliant, but the problem is that there is no interface check. There is no conformity check when attaching an interface to a smart contract because we don't know the functions there. We just know the signatures. Maybe we could check that there are more functions than signature here, but maybe there is some internal working that would make that smart contract work. So yes, I can attach. This is a little surprising, but I can attach. I can even use the wrong interface. I can call hello world, it works. I can change the text ABC, and it changes the text, you see. But if I try to get random text, there is no feature like this. The call would give an error because there is no signature for get random text. It reverted. There is no function get random text as I'm trying to call. The thing is, when I'm doing this call, get random text, the only thing that I'm passing is sending these 4 bytes there. 46A, 0CA, 9E, 06E, 9A. So anyone can call any function signature in a smart contract at any time to see if it answers or if it doesn't answer. I don't need to know the name of the functions itself. You see, I just need to call the function signatures. Okay. When I call a function signature that exists, like this one, the function signature is C605F76C. So this is the function signature of hello world. So it answers. It answers this output here. Okay. Edgardo, do you have a question? Am I pronouncing your name correctly?
I do. Can you hear me?
Yeah, your microphone is a little low, but I guess I can hear.
So my question was, you were saying that we can interact with a function without knowing its name, right?
Yeah.
Exactly how will we do that? How can we interact with a function only with a signature? We could use, I don't know, maybe a door scan or something like that.
Yes, at any time you can send a transaction for that contract with this input, with those 4 bytes, and you can interact with it. A normal transaction, a low level call data here. So if I try to set text to this, you see I'm going to have this transaction data. Let me show this input. Transaction hash, block hash, from gas input here. So this is the call data that I want to pass. You see? So if I change anything here in this call data, let's change those bytes from 43 to 44. If I transact this, the signature is not correct, I guess. Let's see if I can get it. Yeah, I need to sort this out later. But anyone can make this transaction happen to this smart contract just by passing a correct byte. You can even there is a attack called replay attack. You can even look at past transactions that were sent for that smart contract here a few hours ago, and then you can pick the data that was sent in this smart contract here. You don't know what function was called, but you know that the first 4 bytes were these, and then you can repeat, you can replay a call with this input data or tweaking the input data, you see.
Yes. Thank you.
Good, good. And Raja asked about the function signatures. What happens if we have a collisions, 2 methods with the same hash? So the compiler handles that, okay? When compiling a smart contract and 2 methods have the same hash, it can prepend 1 or 2 characters and make that work. The problem is when you are doing a pattern called proxy calls, a proxy pattern that we are going to see in lesson 23. Okay, but from now to lesson 23, you don't need to worry with your hash collisions because the compiler is going to deal with that. Okay, that's a good question. So whenever we're trying to call a smart contract, what we are doing is actually sending those specific bytes. Even if I don't have the function names, I could just send the bytes and it would work, okay? Let me explain that with external calls, which is something totally different from the concept of inheritance that we saw in the past 2 days, okay? External call is when one smart contract calls the other. It doesn't need to inherit the code from one smart contract to the other. It's just one entity calling another entity. Let me demonstrate that for you with a smart contract called greetings invoker. I'm going to code a new smart contract here. Contract greeting invoker. And this contract is going to call another contract inside its function. It's not going to do anything on its own. It's going to call another contract. So I'm going to have one function called invoke greeting that is not going to do anything on itself, but it needs an address as a target. Following the idea? I want to invoke the greetings in that address. You see? That's going to have the same properties of the hello world. It's going to return a string in memory. Okay. Just a question, are you able to follow my code here? Okay, good. So I'm going to create this function, invoke greetings, that is going to return a string. It's public, it's a view, but instead of returning something itself, it is going to return something from the target. I could pick the target address and do a low-level call, like we have in the explanation here. So whenever we have the call, we could do this API encode with signature to this address and this parameter and blah, blah, blah. This is the low-level way for you to do a call, which is a bit of an effort for doing that. Okay, it's not that readable, not that maintainable. Or instead of doing that call, I could do something like a typecast. I would cast this address as the interface of an hello world. Like this. I could cast it with the interface of hello world too, okay? Contracts, they do have interfaces, but both would work for us today. And then I'm going to call the function hello world on it, which we know that is going to return something, and we make it return. Let's see what I did incorrectly. Hello world, this target dot hello world. I'm forgetting. Okay, sorry about that. I have too many things on my screen here. So to recapitulate, this contract, which is another being in the blockchain, now can expose this function invoke greetings that whenever I call this function, I'm passing one address, one blockchain address as a target. And this smart contract is going to try and call the function hello world in that address by using the interface of hello world here. Okay. Let me copy this code for you. And let's play with it. Let's deploy hello world. Let's deploy a greetings invoker. And let's play with it. The text of hello world is like this. I'm going to change for something else. If I get the information from hello world is this, something else. Okay. Now, if I pick the address of this smart contract, hello world, and I try to invoke greetings on it, passing this address, invoke greetings is going to do one external call from a contract to the other, returning something else. And if I change to other thing here, another thing, it is going to pick another thing. But if I pass an address of another smart contract that doesn't implement this, for example, the address of itself, it's going to try and invoke greetings on itself. It gives an error. Transaction reversed. Nothing there. If I pick an address of an EOA, for example, my address, my account, and I try to invoke greetings on that, failed. There's nothing there to answer for that question. See? Why? Because whenever I'm calling invoke greetings, the only thing that I'm doing is try to do this low-level call with those 4 bytes of code of hello world inside the address that I'm passing. This is what the function selector can do for us. Okay. Arda, you have a question?
Yes. Do we need an interface to do this?
We can use the contract itself. It would work just fine if I attach the contract here. See, the contract, every contract has an interface, but the interface doesn't have the contract implementation itself. Okay. And if you don't have the contract, if you don't have the interface, you can either create the interface or do the low-level call, just putting the bytes there, the correct bytes. Okay. I can go forward. I can do something like this. Set greetings. And copy the same structure. And then I can do a function called set greetings in an address, but I would need a parameter of new text. And it's not view anymore. It doesn't return anything at all. It's non-payable. And what I'm going to do is that I'm going to pick the hello world interface at that target to call the function set text with the parameter new text. Yes, smart contracts, they can do that. They can do state changing calls in another smart contract. Contract A can call a contract B, that can call a contract C, that can return and then call a contract D. This is possible. So let me deploy this new greetings invoker. And now I have these two functions. Invoke greetings on this address, should say another thing. Okay, but if I pass this address and the new text ABC, it changed the greetings to ABC inside the contract itself. Look, one contract can change the other. The same way, as simply as an EOA can call a smart contract, another smart contract can call the smart contract too. Okay. And Martin, the way for this to work is just that I can pick those 4 bytes from the code itself. I can decompile those 4 bytes. Or if you have past transactions, you can copy those 4 bytes of code from past transactions if you don't know the interface. Okay. All the information in the blockchain is public. Okay. So questions about interfaces and external calls before I explain about fallback and receive functions. Questions? Yes, Browns, you have a question?
Okay, yes, I have a question. Okay, my question is, I noticed that you got some parameters from the first contract and you place them inside the second contract. I wanted to know, why is it that when you remove the error, I noticed that you had to place new text inside the set text. For example, where you don't have any of those functions and you try to do that, will it bring an error, or what will happen?
You mean when I take this text, this parameter here?
Yes.
Yeah,
So something so different.
this parameter should come from line 21 here. It is required
Yes.
to have one new text. So this is why I need to put it here, you see?
Okay.
Another
Okay.
option would be like I can just hard code something like that. Set text, and then it's going to be like something else, you see? And then I would put that as a call parameter hard coded, see? For this, I wanted to make it dynamic, so I can just do the call here, okay?
Yes, I understand.
Okay. And Vladimir, you asked about security. Would you like to elaborate? What are your concerns about security here? About privacy, maybe? About smart contract calling the order, something like that?
So any public method that our contract have could be executed using this call
Yes.
data externally.
Exactly.
So
So
this
for
is
example,
this
this
is the
is
way
my-
how.
yeah, this is smart contract that we have deployed there. Hello world here. I see that no one tried that, but it's totally possible that you attach your interface to that smart contract. And even though I deployed that smart contract, you can go and call there. I guess someone did. I don't recognize this address. The code input. Yeah, so someone called this. I've come to bargain. Okay. So it is possible. It's not a security risk. Okay, it can cause hacks, of course, but it's not a security risk because it's a feature of Solidity, of the smart contracts, actually, not even about Solidity itself. Anyone can call any function. Anyone. So long as it's public, anyone can call it. Hey, but if we want to restrict the function calling to certain people, what if I want to restrict so that only I can change the text, so that who can pay change the text? So we're going to do this exercise just in a while, implementing access control, okay? Using interface and doing this access control thing. But for now, you are 100% correct. This could be a problem. People could come and call my smart contract to say, you are hacked, I came here to bargain, okay? I don't know who did that, but someone sent this string. That's good, okay? Yes, Laurent, yeah, I don't have the possibility of tweaking the size here, I guess. I can just hide or something like this. Remix interface is not that great for screen sharing. Guess I can do something, yeah. What I could do is decrease the font size, but then it becomes a little less readable. Is that good?
For me, it's better. I don't know for others.
Yeah. Okay, good. If you're not following, let me know, okay, people? These codes that I'm using here, they're not important for making the weekend project or the function or the exercise to work, okay? It's just examples. And I want to get used to exercising this, okay? Of course, I can copy here and paste in the chat so you don't stress out about typing super fast. But the most important thing is that you understand and that you can play out with these things in the future. I want you to use this smart contract as a playground, okay? Hey, what if I put this? What if I use a number instead of a string? Hey, what if I do this order a function to change the text to what was before? What if I keep a history of text? I want you to play out with this. This is going to be your teacher now, okay? Testing out this smart contract is going to be a path for you to understand Solidity, okay? Any other questions up to these external calls? Now let's play with those. The person that used your contract need the address of the deployed contract to do so. Yes, Nathan. I've sent this address in a few past lessons. So this is the address of my smart contract. If you have the interface, you can call it. Okay, I'm going to recapitulate that in a while. So there are some special functions that we can put in a smart contract. One of them is the receive ether function, and the other is the fallback function. Let's start with the receive because it's very straightforward in what we can do. By default, smart contracts cannot receive money. When I transfer money from my address to your address, it works perfectly. Like no one is going to check anything in the blockchain. But the smart contracts, no. If I pick like my hello world contract here, let me deploy. And if I try to send money for it, let me put like the value of 1 ether. And if I send money to it just by itself, it's going to give an error. In order to receive ether transfer, the contract should have either a receive function or a payable fallback function. This contract hello world doesn't have any of these. I can even increase this one a little more. I'm going to create this receive function. This receive, if I do this, receive, extendable, payable, blah, blah, can do some computation whenever a call to the contract is done with an empty call data and a value on it. I'm going to execute this receive function. Okay, so this receive function, this contract here, this contract that I'm putting here, the hello world smart contract cannot accept money, but if I put this receive function here, external payable, now I can receive money. Let me deploy this hello world again. What's happening? I had some thing there, sorry. So now if I try sending 1 ether to it, it just goes, and I have 1 ether in the smart contract to see. Okay, this is the receive ether. Okay, it enables a smart contract to receive information, or to receive donations. Okay, good. But what if I pass a function that doesn't exist, like the get random text, or I can have another function, something like this. Function, I'm going to put that in the interface. Function. Call wrong execution. Okay. I'm calling it wrong because I don't have any method that would match to this, okay? So it is external. I'm going to put it as a non-payable, okay? And just like that, I'm passing this function in my interface. Call wrong execution, okay? And this smart contract, hello world, doesn't have anything as a call wrong execution. Let me remove this receive function here. Okay. Let's append this call on the greetings invoker. Let me append this function. So function invoke wrong call or invoke wrong execution. In a target. It's going to be public. It's going to be callable from the outside. And I'm going to do the I hello world in the target. And I'm going to call the wrong execution. Just that as it is. Okay. Let me pause here for a minute to understand to explain what is happening. I created a new interface called wrong execution. We don't have this function in the hello world, of course, like the other one that I demonstrated. And now in the greetings invoker, I have this function here to invoke invoke wrong execution. Pasted here in the chat too. As we saw in a while ago, we expect this to fail, right? And it's correct. If I deploy a hello world and then deploy this greetings invoker and pass the address of the hello world to the greetings invoker and call invoke wrong execution, it's not going to work. It reverts, okay? Normal, as we would expect, because there is no function signature in the list of functions there of that hello world that would comply to call wrong execution, so it fails, okay? Now I can code this fallback function, and look how interesting. This function can be executed, can be invoked on any call to the smart contract if none of the other functions would match the given function signature. So I would have like a fallback case, a catch-all case, that if no other functions were triggered, I would have there in my smart contract a function to catch all and do some operation. For example, let me put a fallback here. External, I don't want it to be payable, just external. And this fallback function is going to set the text as equal to wrong. Okay. You're following? I'm putting a catch-all case, a fallback case, so that if I call a function which is not the hello world, the set text, or the initial text, it's going to trigger this fallback and it's going to set the text to wrong. Gotcha? So I'm going to deploy this hello world again with the new version, with the new code. To deploy it with this fallback function here. And now I'm going to call in this address of hello world. Let me invoke greetings first so that you see that I have hello world here, okay? I'm going to call in the address of this new hello world with the fallback function, the invoke wrong execution. It was failing just a while ago. Look here in the bottom. This was actually reverted because it didn't have the function selected, blah, blah, blah. Yeah. But when I call this invoke wrong execution, now the hello world is wrong. Wrong. You see, let me clear that. Let me put ABC here. The hello world is set the greetings. Sorry. ABC. Okay, so the hello world is ABC. Okay. Invoke greetings, ABC. If I invoke this function, invoke wrong, it's going to go for the fallback, it's going to set the text to wrong, and now the hello world is wrong. Invoke greetings is wrong. See? Okay. And this is a big subject. Yes, fallback. Now you call it, well, fallback functions, they are used in proxy patterns, they are used in a lot of different patterns, and it can cause hacks, external calls are tricky, controlling the flow. So we're going to have an entire lesson just about security problems. Okay. Can you call a fallback function directly? Yeah, for calling a fallback function, you just need to call a function like with any signature 00001 like this, you know? You don't need to actually type fallback or anything like that, okay? Any call that you do for any signature which is not declared by one of the best functions would trigger the fallback. So receive, when you want to receive ether, you can make the fallback as payable to things like if the MSG value is higher than 0, you put the text as thank you. Otherwise you put wrong or something like that. Okay. Directly calling fallback. What do you mean? Like calling fallback from here, like this? I mean, you asked about we cannot target the fallback directly. The only way to target the fallback function is when we call this smart contract from the outside because it needs to be external. And it doesn't match any other function selector in the smart contract, okay? Good. So Browns, the explanation here is that this fallback function now is going to pick any call that I make to the smart contract that does not match the function selector of none of those orders. It doesn't match the function selector of hello world, doesn't match the selector of set text, doesn't match the selector of initial text, then it would trigger the fallback. Okay. That's the idea here. I did here with an external call, but it could be done with an interface too. I can pick the interface, hello world, attach that to this address, and I can try from here. Hello world is wrong. Set text to ABC. So now the hello world is ABC. Call wrong execution. Now hello world is wrong. You see? Get random text. Returned nothing. Because the fallback is not returning anything here. Okay. With these understand the function selector, the structure of the smart contract for handling function calls. They receive either the fallback function. Now, with this explanation, you now understand what is going on there in the EVM when you are doing these function calls. And maybe now we would agree that, yes, it's interesting to have all of these definitions. When we look at the grammar of solidity, let's go for that again. Where's the grammar again? Try and find language grammar. When we look at the grammar of solidity, lesson 2, and we go for the function definition, and we see it all, it seems like a badly designed language, right? Oh, why do we need to do all of that inside the function call? Wouldn't it better to infer it from the implementation, blah, 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 no? Now we know why. Because there's so much at stake, the selector itself, what's going to happen, how the function call is going to be handled, that now it makes sense. Oh yes, I need to declare it as public already because then the EVM is going to put that in a way that it can be, the signature can be called from outside and from inside. Oh, okay, I'm going to put view so that I can attach this function call to the block storage, but at the same time, I don't need to handle payments. Okay, it's returning that. Okay, so I'm going to put that in the ABI, you know. So even before we start coding the function itself, the EVM is prepared for handling all that is going to happen inside. Okay. So this explains a bit of why Solidity is it is. Not saying that it's a perfect language. The people that did this are the biggest genius in the world and all. They are very good in what they do. There are flaws in Solidity, of course, but this is not a problem. We shouldn't need to switch for all the programming languages because we don't like this, because actually this is a reflection of the architecture of the blockchains itself and not actually a flaw of the coding language. So learning Solidity is very useful. Instead of coding with Rust or Python, whatever, you can learn Solidity to better deal with those implications of blockchain, okay, to follow the best security rules possibly using this custom language. Okay. So this finished the explanation about the language itself. I'm going to do one exercise with you today that is implementing access control. Okay. We saw a while ago, we were discussing about the possibility of someone else calling my smart contract, changing the text. Vladimir asked about this too. How would we protect the smart contract? So I suggest this little implementation using access restrictions. Okay, let me show that for you. There is these patterns of restricting access that can bar some people that would stop some people from doing specific things on your smart contract. There are many different access restriction patterns that you can do. We're going to see a few of them in this bootcamp. The most simple one is the owner. That would be the person that created this smart contract. Okay, I could do an access restriction, for example, on time, like the creation time. And if whomever is calling is not authorized, it would give this error. If whomever is calling too early, it would give this error. You see, so there are different ways that you could handle access restriction, but all of that is coding on top of your smart contract, not in the underlying infrastructure. You would code these access restrictions logics yourself. Okay, so for example, in this smart contract, anyone here can call that a set text a function, right? Let me clear this up a bit. Okay, let me clear this up. Clear this. We get a bit closer to what I have here. Okay, this is the simplest version of this hello world for us to start. I have this one state variable. The constructor is setting the value of that variable to hello world. Okay, and I have one function to read and one function to write that variable, like a simple storage. Okay, but now I want to restrict so that only my address can set the text. There is no underlying way for coding, for making this happen. But yesterday I have demonstrated a few ways for us to get these values from the function calls, and we can code on top of that. So what I want to do is to make the transaction fail if the color of this transaction is not my address. Okay. This is the to do here. Let's do that together. We have time. We have more than half an hour. What is the command to make the transaction fail again? I have three of them. What would you suggest me to use? Avert, require, assert, all of those are good, right? So if not something, I could revert, or I could require something. I could require that the person sending this transaction equals to my address. Something like that, right? Require the person sending this transaction equal to my address. Or if person sending this transaction is not equal to my address, revert. Both would work, okay? Usually requires are more common to see. They already express a thing. You don't need to do a double logic. Like if not this, then I did that. Okay, no, I actually just require. Like if it's not raining, then I don't pick an umbrella. Wait, no, okay. I require that it's raining to go with the umbrella. Something like that. It can be more straightforward. Okay. So what is my address? Let me pick my address here. This is my address. And let's see if you recall from yesterday, I demonstrated very quickly how to get the person sending this transaction. I can pick from MSG sender. I require this. Okay. Browse, you have a question?
No, I just wanted to answer it.
Okay.
Okay, from what we learned yesterday, I think we should create a state variable and call it address public owner, and then will be like message.sender is equals to the owner. Then we'll now give a reset or like a string error here inside the sets text. So
Yeah, you're going to get there eventually. One step at a time, don't worry. Okay. So this function set text now, if I deploy it, let me deploy that smart contract with it. I am the owner, 5b3. I can get hello world. I can set text to ABC. Okay, good. ABC. But if I try to change with another account like this AB8, and I'm going to try and do like this, hack it. It worked. The function reversed it. I had the hello world. This is still ABC. Okay. Did you get that? There is no underlying access control in the base of the smart contract execution, but I can code. It's very simple to code this kind of logics on top of my smart contracts. I would need to do the correctly required, can be with a time, can be with an owner, a person, a string, a payment. I can do a lot of access control logics, custom logics on top of my smart contracts. Okay. Any questions up to this point? And yes, you might be a little anxious for implementing it in the correct way here, but I'm going to guide the exercise until there. Okay, don't worry. Trust. You want to ask something?
Yes. I want to ask something. I was wondering about that message of sender. Is the message of sender, is it the address of the deployer or the address of the person interacting with the smart contract? Can you hear me?
This is the address of the deployer, the account that deployed.
Okay, that is the message of sender is the account of the deployer.
The message sender is whomever is calling that smart contract. Is the account that is calling that smart contract.
Okay.
I can demonstrate that very quickly during this function. Example. It is public. Dio turns address and then return MSG sender. Okay. People, I expect that you know how to do these things now. For example, I can deploy this hello world, and I want to know what is this MSG sender. You can just do this example. Okay, the sender is this address. It's the address that called this. Now I'm going to pick the other address, and the sender is this other address. You see, the MSG sender is always going to return whomever is calling. Okay. Good. And if it's been called from another, a smart contract is going to return the address of that smart contract. Okay. This is a nice exercise to do. And Nathan asked about hard coding the address here. So it's not a security risk. It's actually a design flaw in some ways, but it's not a security risk because no one can edit this. I could do an external call. Yes, I could do like the invoke a contract and to do an external call, but I wouldn't be able to change that line 16. It is going to be hard coded like this forever. Okay. It's not a security risk. Okay. Good. But this is an inconvenient because now if someone else wants to deploy that smart contract, they would need to hard code this line again and again every time that they would deploy from a different address, right? It's not very convenient. So how to get the smart contract deployer, like this dot deployer. Is there any way to get the address that deploy the smart contract from the variables? Did you see anything like this in the list from yesterday? There is no variable like this. Okay, so then we need to code it from scratch. Before I do that, I guess we have a question from Abhinav.
Yes, sir. I was asking whether we can initialize the address of the person who deployed the contract in the constructor itself.
Exactly. We can, let me create this variable there. Right. Let's call it owner. Okay. Owner equals to the MSG sender at the constructor. The person deployed is going to be the owner. But how to get the owner from the constructor? Like constructor dot owner. I cannot get this variable from line 9 here at line 17. There is no way for me to get this variable. Do you have suggestions on how to solve that?
We can initialize it outside the constructor, just like the
Yeah,
text.
and save that in a state variable. So an address, owner. Now I can set the owner here and use the owner there. Make sense? And I know that all of you were anxious with that. I was going slowly explaining, because ideally you can now code this kind of stuff by yourself. Oh, so I'm going to need this variable. Okay, but then I need to use it here and there. So I want to give it a little freedom for you to follow this chain of thought for doing your own modifications in that smart contract. Okay. Let me show a little detail for visibilities of state variables. Whenever you mark a state variable as public, it doesn't mean that it can be changed. It is not like a security problem or anything like that. When you mark a state variable as public, it gets like a free getter. Not like a free, but the compiler codes a getter for you, so you don't need to code it yourself. Okay, let me show that. I'm going to deploy hello world with this variable owner. So I have one view function, hello world. Okay, but if I deploy it with a public owner, let me deploy it. I have two view functions, one hello world and the other is the owner. Okay, it's a little detail, but it's very useful. It doesn't mean that I can change the owner. Okay, it's just that the compiler, when compiling this smart contract, is going to create that function to read the owner so that we don't need to code it ourselves. So instead of coding this function hello world, we could have just done the string as public. It would work. That is true. 1 week on top of that, and we just discovered that we could have simplified that smart contract. Okay, let's keep it as it is. Questions about this owner implementation here? Any questions? Edgar?
Yes, I do have a question about how to implement the interface using the ABI.
Implement the interface?
Using the ABI, if I have the ABI of a contract, how can I turn that ABI into an interface?
okay, for example, the ERC20 ABI, something like that. And you want to implement the interface, right? So you see that you have the name of the functions here. So it would be a function with the name with the outputs of a string that is not payable. So there might be online conversions for this, but ideally you have all of the information that you need for creating that interface, right? Then you can start coding interface, ERC20, visibility, external, the function name is going to be name, pick another function. Function A is going to be approve, then it's going to require these three inputs, so then it's going to give these two inputs, sorry, then it's going to give this one output is not payable, okay? You have all of the information that you need for coding these functions here, right?
Okay, and I have another question about state mutability. It's about the pure flag. I couldn't imagine a use case for that, and in the code we have used throughout the course, we haven't really used the pure flag.
Yes, pure functions are much more common when you have like, let me pick an ERC 721. ERC 721. When we have when we have constants, for example, in the ERC 721, that is some constant that would be the URI of that smart contract. Let me see if I have this. I guess it would be in a derived one. Whenever you have a constant, imagine, or whenever you have a multiplication between two things, I can see a lot of examples that in string manipulation libraries, for example, string manipulation library, Solidity, GitHub. So these functions, they wouldn't use any kind of state of the blockchain itself. For example, the code itself. So for example, a function to slice a string, picking another string would be pure. A function to get the length of a string, it would be pure. I would just calculate the length of that string. A function to copy a string would be pure. A function to cast object to string would be pure. A function to calculate the length of a string would be pure, you see? Because I don't need the state of the blockchain itself. I just need to compute on the things that I have received. Okay. Make sense?
I understand. Yeah, thank you.
Okay. So let's move forward for the exercise that we have here. Any of these open questions, and now people, please be free to at any time to ask questions on GitHub as soon as possible. I can answer there. About the lesson itself that we have right now, implementing access control, we have this way of calling the set text as the owner or not being the owner with this button here. The code that I have here as a reference for us. It's very similar to the one that we have right now. It's just that now we have this modifier on the owner. So incorrect casing. Do you remember about this modifier? That I can prepend on function executions? Or append action on function executions. Only owner is going to check if the MSG sender is an owner. Otherwise, it's going to give this error. Color is not the owner with this string. And then it would fail. And I also have this function transfer ownership that would make the owner equal to the new owner, but it needs to be called from the owner only, okay? Let me show this smart contract for you. We're going to use this smart contract in the weekend project, so it's important that you know how to use and navigate through it. I have deployed that smart contract with the account 4B2. So if I click on the owner, I'm going to see that address. If I set the text, it should work for me, okay? But if I try to set the text with another account, like the first account, it won't work. If I try to set the text to something else, it's not going to work. It reversed it with the reason color is not the owner. See? But if I pick the deployer account 4B2, that is the address, and I transfer ownership for this new address, transact, transfer ownership, the owner changed. So now if I try to set the text to something else, it doesn't work. I don't have access. I don't have writing rights on this smart contract. But now the first account, the other account that is now the owner I can change it for something else. You see? Now I have this small control flow structure implemented there. Okay. Laurent, you have a question?
Yes, when you deploy a contract and you play with the inputs, sometimes you delete something. Does it mean that there are several contracts deployed with the same example, or it's for another reason that you click on the delete? Yeah, just here, deploy contract 1. Yeah, why do you delete here, just for clarity?
Yeah, because then if we have a lot of contracts here, we could get confused. We could use a contract instead of the other. So since they are all named Hello World.
So my
Antenna
question
would
is,
be,
when you redeploy a contract, it adds up a new one?
yeah, it deploys in a new address.
In a new address. So it's the same source code, or you modify the source code, but when you click on deploy, it generates the contract on chain on a new address, right?
Exactly.
Okay.
It's
Fine.
not possible to change a contract that I deployed in the past. So every time that I want to deploy, I would get a new implementation, a new instance, okay?
So whatever the change, even one character, when you redeploy, it's a new address.
Exactly.
Okay, thanks.
Exactly. Okay. And Lai, I'm going to speak about the homework in 7 minutes or so. Just finishing here. Okay. Any other questions about this control flow structure? This owner structure that you have right now? If not, I have a little challenge for you. Do you remember what is this character in the modifier? This character is going to govern when I go back to the execution. I could do some things before, I could do something after. Okay, this character would govern where I go from the modifier to the function itself. Okay, but what if I put this character on top? Would it work?
It won't work.
Let me see. Let me test. I'm going to deploy this hello world.
This will first
When
run the
I
function.
try to set text, the owner is, let me see, the owner is 5B3. When I pick the AB8, I'm going to call set text. It's going to first write text to something else, like hacked, and then it's going to check this requirement, right? So the text has already changed. But do you remember that require would reverse all the changes? So let me call this set text here. I'm using the owner. I am the owner. Okay. So let me change for AB8. Good. So if I try to set text, it still fails. Color is not the owner, and text is still hello world. Okay, so the require statement, even though it was computed after the text changed, the require would revert the transaction to the initial state. It would cost more gas up to that point, yes, but it would revert the transaction to the initial state. Okay. And also, if I try to transfer ownership for someone else, let me try and transfer ownership for this guy here. It also fails because I'm not the owner. Caller is not the owner, right? It seems like it is working because it's stopping another owner, another address other than the owner for setting text and to transfer ownership for other people, right? But I assure you that that is a problem. And this problem is not easy to detect, but is a good exemplification of how those hacks they happen. Sometimes one edge situation would get you, one single case would get you that it's very difficult to detect beforehand. Yes, Browns, you have a question? Or maybe you saw the problem here?
Okay, yes. The problem here is that the underscore with the semicolon is meant to be under the required function, because from my little research before class, I noticed that the required function, sorry, has to be above it, so that when it's compiling, it's compiled from the required function with the semicolon, because with the underscore and the semicolon. And I think the underscore and the semicolon means, or is a situation where it's just continues till the end of the contract. I think so.
Yeah, putting the underscore semicolon before the require is doing the functional execution first and then doing the requirement later, which so far is not a problem, right? Because I could stop people from setting text and I could stop people from transferring ownership, right? So far it's working. There is just one edge situation where it's not working. And it's difficult to detect, but if you think a while, you can detect. And this is a good example of how those hacks works, because you test thousands of things and all of them are working. Just one edge situation that you didn't think of, it's not working, and then you can get hacked. Okay, it would execute the function before the modifier, and Nathan said that is okay, yes. Raja said it would defeat the purpose. Well, it's still working on two situations here, most of the case. Do you want to think on this for an extra minute? See in what situation this would be a security problem. Yeah, Browns?
Okay, I think is the language pattern. I think the constructor is meant to come above the modifier.
Okay, let's see that in the style guide. The order of layout. Okay. So the modifier type, no, the modifier would come before the functions. So first you do the type declarations, then the state variables, and then the events, and then the errors, and then the modifiers, and then the functions. Okay, so the state variables, the modifiers, and then the functions. Okay. Let me see here the chat. How about Raja asked, how about if the called function changes the owner? Well, I tried. I'm not the owner. The owner is 0x5b. I am AB8 and I tried to change the owner for 0x787. It failed. So even though the check is happening after, it is still working for me, right? Naya, Nathan, because you're close. You want to go first, Naya?
Yeah. Can't you just recall because every time you call the contract and like redeploy the contract, it changes the owner. So if you redeploy the contract, you would become the owner and would have the ability to do whatever it is you want.
Yeah, but would you see that as a security risk?
I suppose not, because it would just change the address, so it wouldn't be the original contract, right?
Yeah, it would be a forked contract. Which is by design. But you are correct. If I deploy a new contract, I would be the owner of that new instance. But I guess that Nathan found the problem here. I could hijack this we could hijack this smart contract, this deployed smart contract by transferring the ownership to myself. And I know this is a very small change, but if I copy my address here, and if I put my address and transfer it to myself, it would work. And this is a problem. Now the contract was hacked. Just because one line of code, one little difference like this, make my contract hack, make me lose billions. Because what happened is that I first set the owner as the new owner in line 27, and then I require the MSC sender to equal to the owner, which it is. The owner was just overwritten in the last line. Okay, every single line is important here. Okay, so it would work in most of the cases, just one case that it fails. In this situation, it's very easy to detect, but imagine that you are building a smart contract that handles billions of dollars of volumes and on. That is one little case where you could withdraw that money without being the owner. Okay. So then you would have this problem. Okay, so pay attention to everything that you do with Solidity. Thank you all for contributing. Yes, again, Roger, you got it correctly before too. Naya, do you have a question? Do you see the problem here?
Yeah, I wanted to ask, I understand the problem as you're explaining it. I'm wondering how you would, like, after you deploy the contract, or even if you were doing on like a test net to like see what the security issue is, how would you test this? Like, how would you figure this out from an
It's
outsider
difficult. It's
perspective?
almost like a detective, you know. I'm going to show that through 2 weeks. Week 2 and 3, we're going to do a lot of testing first. Now that we see how critical this is, I'm going to show how you can use techniques and tools that we use in the factory to reuse in our smart contracts, how you could properly try and cover for all of those scenarios, okay, when you are coding a smart contract. I'm going to do 2 weeks on that, so don't worry. The most important part of this bootcamp is to know how to code safely, securely. Even though it's a beginner bootcamp, it's very comprehensive. You should be able to code well after this bootcamp. Okay, so we did this code contract interactions. We did all of these bullet points already. I want to give you some extra reference material and homework for you to do before lesson 5. I'm going to stress a lot on this. Lesson 5, we're going to stop using Remix and we're going to start coding the things on your own machine. For that, you need to have the Node version 20 on your development environment. There is no time to install that on lesson 5 on next Monday. So you need to do that before. You should have NPM, you should have Yarn. If you like, you can have Bun too. You should have Git CLI, you should have VS Code or any similar to this like Cursor or anything like that, because this is going to be extremely important for lesson 5. If you don't have this, you are going to lose most of lesson 5. Lesson 5 is actually just guiding you through installing your own environment, okay? We are not going to use Remix anymore. We're going to use your own computer, your own device, so you need to know how to use the command line tools, how to use your terminal, bash, whatever you have there on your operational systems, and you should be able to run node and npm commands, okay? I also ask you to create free accounts on those 3 providers, just so that you have them for calling RPC nodes, RPC calls. When you want to make transactions to blockchains, you need those accounts, and they are free. We're going to need that before lesson 8, okay? So the first homework is setting this up in your machine. Super important. You do that alone, you and your machine, and you should have that done before Monday, okay? It's not something that you deliver. It's something that you need to do for following lesson 5. We are using hard hat, okay? So you can go ahead, look at it, so you know what to expect. As for the weekend project, something that you would deliver, you're going to use Remix connected to your injected provider, MetaMask, whatever you have, in a testnet, Sepolia, or any network that you would prefer. You are going to pick the hello.sol that we have right now with the owner stuff, with the transfer ownership functions and all. And you are going to interact with it within your group to change the message strings and to change the owners. And then you're going to see what kind of errors happen when you are the owner, when you are not. You're going to change this string in the contract, and everyone else should be able to see by clicking on the interact button, on the hello world button, and now you're going to write a report, open-ended. Don't stress out with the format for this. Can be a Google Docs, can be a Notion page, can be a spreadsheet, can be a picture of a piece of paper. Don't worry of that. Or it can be a text, a CSV. The format doesn't matter. We just want to see the executions of each functions and transaction hashes to see that it happened on the blockchain. And if you call, for example, transfer ownership without being the owner, or set message without being the owner, it should revert. We want to see those revert reasons, just so that you know the control flow, you understand the structure of the smart contract, okay? You have a group of 5, 6, 7 people. I don't know how much we have per group in this cohort, but you should do that round robin. Like one person deploys, then the other try to call, then transfer ownership, and do that round robin between your group, everyone that is online contributing, and then you write this report, okay? You're going to have a form for that. I don't have access to this form, but Nevin or one of the program managers, they're going to post that on the README channel on Discord. You go there, you fill the form, 1 per group. 1 person of your group fills the form. You have the report there with all of you interacting, okay? You can use Sepolia, testnet. You can use any other testnet. You can use like Polygon or Coinbase or whatever chain that you want to use in testnet. If you have money there, you can use. You can use mainnet too if you have a lot of money. Okay. The chain that you use is not important, so long you give us the link to check in the Explorer or do that on Sepolia. We can follow from there, okay? Should be very easy and quick, about an hour or a couple of hours maximum, and you would have this first experience with your group. Next weekend's projects are going to be a little more difficult. It would require a little more of dedication, but this first is just the introduction for it, okay? At least 3 students, okay? At least. So 4, 5, 6, 7 would be better, okay? You should deploy a new smart contract, otherwise you wouldn't be able to transfer ownership, okay? You should deploy a smart contract so that you can change ownership. You should see the groups in Discord, okay? Go there for Discord, check if you have the group there. If not, you should contact a program manager, a Zap, okay? It's not needed to verify the contract, okay? It's optional, but you can, it's very easy to do if you want. Okay. Good. I guess this is it. I also put some extra reference material for next week, because we're going to use a lot of TypeScript, a lot of JavaScript, so you can give a read on this extra reference material too. If you don't know anything about TypeScript at all, you should give a look on this link. It's a very quick link for you to go through. You don't need to be able to code proficiently in TypeScript. You just need to be able to understand the syntax, okay? So go over this very quickly and you should be able to follow us in next lessons, okay? And I guess this is it. I hope you enjoyed this first week of lessons. I hope you enjoy the weekend project, have some fun. I'll be in SF next week. If anyone is around, let's hit up something and get some pizza together. And I hope that you would follow up next week, would keep dedicating yourself, and eventually we're going to have a new batch of 53 new EVM developers. Okay, thank you everyone. Bye bye.